Welcome to my channel. Today we will talk culverts. First we know WAFs culverts, types of culverts, material used to construction culverts. If this is your first time visiting our channel, please subscribe to keep up to date with our videos. Thank you for getting started. The culvert is a small channel that allows water to flow under road, railroad trail or similar obstruction from one side to the other, typically embedded so as to be surrounded by soil. A culvert may be made from a pipe, reinforced concrete or other material in the United Kingdom. The word can also be used for a longer artificially buried watercourse. Culverts are commonly used both as cross drains to relieve drainage of ditches at the roadside and to pass water under a road at natural drainage and stream crossings. A culvert may be a bridge-like structure designed to allow vehicle or pedestrian traffic to cross over the waterway while allowing adequate passage for the water. Culverts come in many sizes and shapes, including round, elliptical, flat-bottomed, open-bottomed, pear-shaped, and box-like constructions. The culvert type and shape selection is based on a number of factors, including requirements for hydraulic performance, limitations on upstream water, surface elevation, and roadway embankment height. Material: steel corrugated culvert with a drop on the exhaust end. Northern Vermont culverts can be constructed of a variety of materials, including cast-in-place or precast concrete, reinforced or non-reinforced, galvanized steel, aluminum or plastic, typically high-density polyethylene. Two or more materials may be combined to form composite structures. For example, open-bottom corrugated steel structures are often built on concrete footings. Design and engineering: a culvert under the Vistula River levee and a street in Warsaw. Construction or installation at a culvert site generally results in disturbance of the site's soil, stream banks or stream bed, and can result in the occurrence of unwanted problems such as scour holes or slumping of banks adjacent to the culvert structure. Culverts must be properly sized and installed and protected from erosion and scour. Many U.S. agencies, such as the Federal Highway Administration, Bureau of Land Management and Environmental Protection Agency, as well as state or local authorities, require that culverts be designed and engineered to meet specific federal, state or local regulations and guidelines to ensure proper function and to protect against culvert failures. Culverts are classified by standards for their load capacities, water flow capacities, lifespans, and installation requirements for bedding and backfill. Most agencies adhere to these standards when designing, engineering, and specifying culverts. The hydraulic design of culverts, culvert end treatment, the design of scour protection, debris control, and an introduction to improved culvert inlets. The procedures for the hydraulic design of culverts are based on hydraulic design of highway culverts. Hydraulic engineering circular, U.S. Federal Highway ADMINISTRATIO, 1985. The emphasis in this chapter is on the design of culverts for urban stormwater drainage. Design considerations: headwater: any culvert that constricts the natural stream flow will cause a rise in the upstream water's surface. The total flow depth in the stream measured from the invert of the culvert inlet is termed headwater. The available headwater will depend on the topography of the site and the vertical road profile in relation to that topography. In flat or undulating country, or where a high standard vertical road profile is used, the available headwater may be limited by the height of the surrounding ground or the elevation at which the road formation cuts through the hydraulic grade line. Raised levee banks may be necessary to maintain the headwater depth required as indicated in section. The most economical culvert is one which utilizes all of the available headwater to pass the designed discharge, since the discharge increases with increasing head. However, it is not always possible to utilize all of the available headwater because of constraints which limit the upstream water level. Selection of the design headwater should be based therefore on consideration of the following factors: limits on backwater resulting from the presence of buildings upstream and or the inundation of agricultural land. The outlet velocity and the potential for scour. Potential damage to adjacent property or inconvenience to owners should be of primary concern in the design of all culverts. Expensive court cases and resultant compensation may result if property owners' rights are neglected. In urban areas, the potential for damage to adjacent property is greater because of the number and value of properties that can be affected. Culvert installation under high embankments in rural areas may present the design engineer with an opportunity to adopt a high headwater and allow ponding upstream to attenuate flood peaks downstream. If deep ponding is considered, the consequences of scour at the outlet and catastrophic failure of the embankment should be investigated. When culverts are installed under high embankments, an appropriate investigation should be made to evaluate the risk of a larger flood occurring or blockage of the culverts by debris. Culvert in plan: ideally a culvert should be placed in the natural channel. A culvert in this location is usually aligned with flow, and little structural excavation and channel work are required at the inlet and outlet, especially for shorter culverts. culverts. In the case where location in the natural channel would require an inordinately long culvert, some stream realignment may be required. Such modification to reduce skew and shorten culverts should be carefully designed. Environmental concerns for stream velocity, flow depth, and factors important to the stream ecosystem, and hydraulic concerns for stream bed and bank stability make it advisable not to undertake channel modifications unless there is no practical alternative. Culvert skew should not generally exceed 45 degrees, measured from a line perpendicular to the roadway center line. If the skew is greater than 45 degrees, special consideration needs to be given to the hydraulic efficiency of the wing walls. Culvert alignment square to the road center line are not recommended, where severe or abrupt changes in channel alignment are required upstream or downstream of the culvert. Small radius bends are subject to erosion on the concave bank and deposition on the inside of the bend. Such changes upstream of the culverts result in poor alignment of the approach flow to the culvert, with resulting loss of hydraulic efficiency, subject the embankment to erosion, and increase the probability of deposition in the culvert cell. Abrupt changes in channel alignment downstream of culverts may also cause erosion or deposition of material in adjacent properties.